Hi everyone. In this video, we are going to see how a TI-84 calculator can help us quickly find measures of center. In the previous videos, we learned how to calculate the mean, median, and mode by hand. That's an important skill because it helps us understand what these measures represent. However, when working with a larger data set, doing all of those calculations by hand can take a lot of time. That's where technology becomes very helpful. Let's begin with example 5. We're given this data set and we want to use the TI-84 calculator to find the mean, median, and mode. Round the answer to 2 decimal places. Hey everyone, in this video, I'm going to show you how to use the TI-84 calculator to find the mean and median. To enter the data into the calculator, press Stat, choose Edit, and press Enter. You see several lists labeled L1, L2, L3, and so on. You can enter the data into any empty list. I'll use L1. 34, enter. 42, enter. 18, enter. 42, enter. 51, enter. 28, enter. And 42, enter. Once you've entered all the values, press Start again. Move over to Count menu. Select the first one var stats, and press Enter. When prompted for the list, choose L1 because I stored my data in L1. Now, if you store your data in L2, then you should replace it with L2 by pressing second 2. And if you store your data in L3, you will need to replace it with L3 by pressing second 3. Second 4 for L4, second 5 for L5, and second 6 for L6. So now let's replace it with L1 because I stored my data in L1. Second 1. Leave this frequency list blank because we didn't have any frequency. Highlight Calculate and press Enter. From this screen, X bar represents the mean. So our mean is 36.71. Use the down arrow to scroll down the list. Med is the median, so our median is 42. The calculator helps us calculate the mean and the median. But the calculator does not automatically give us the mode. So we need to identify it by looking directly at the data. Let's count the values. The number 42 appears 3 times, and every other age appears only once. Since 42 occurs more frequently than any other value, so the mode is 42. Notice that these values are not all the same. That's perfectly normal. Each measure of center describes the data in a slightly different way, which is why it's often useful to look at all 3. Now, let's look at one more situation where we might want to find the mean. Up to this point, we've been working with raw data. In other words, we have had access to every individual observation. For example, in example 5, we were given the exact ages of all employees. Because we had every data value, we could add them together and divide by the number of observations to find the mean. But sometimes we don't have the original data available. Instead, the data are summarized in a frequency table. A frequency table tells us how many observations fall into different classes or intervals. For example, instead of listing every value individually, a frequency table might tell us that 2 observations fall between 10 and 14. 5 observations fall between 15 and 19. 7 observations fall between 20 and 24. Frequency tables are useful because they organize large amounts of data into a compact format. However, there's a trade-off. While the table is easier to read, we lose some information because we no longer know the exact values of the individual observations. That creates a challenge. Remember the formula for the mean? To find the mean, we need the sum of all the x values divided by the number of observations. But if we don't know the exact x values, how can we find the mean? That's where the class midpoints come in. Since we don't know every value in a class, we use the class midpoint as a representative value. The midpoint serves as our best estimate for the observations within that interval. Then we combine those midpoint values with the frequencies to estimate the mean. So the process we are about to learn is really an extension of the mean formula we have already learned. The goal is still the same. We are still trying to find a typical value for the data. The difference is that we are now working with group data instead of raw data. Let's look at an example and see how this works. We're given a frequency table with 3 different classes and their frequencies. We want to estimate the mean and round the answer to 2 decimal places. This table does not list every individual data value. Instead, the data have been grouped into classes. Because we don't know the exact value in each class, we cannot calculate the exact mean. Instead, we'll estimate the mean using class midpoints. So first, we need to find the class midpoints. To find the class midpoint for this class, we take 10 plus 14 divided by 2, which is 12. To find the class midpoint for this class, we take 15 plus 19 divided by 2. That equals 17. To find the class midpoint for this class, we'll take 20 plus 24 divided by 2. And that is 22. Next, we are going to use a calculator to estimate the mean. The class midpoints will act as our x values because they represent the observations in each class. The frequencies tell the calculator how many times each midpoint should be counted. So in the calculator, L1 will contain the midpoints, and L2 will contain the frequencies. Hi everyone. In this video, I'm going to show you how to use a TI-84 calculator to estimate the mean from a frequency table. Press Start button, choose Edit, and press Enter. In the list L1, enter the class midpoints. Move over to L2 and enter the frequencies. Take a moment and double check your entries. Remember, the midpoints go in L1 because they are acting as our X values. The frequencies go to L2 because they tell the calculator how many times each X value occurs. Once everything is entered, press Stat again. Move over to Calc menu. Choose one var stats and press Enter. For the data list, enter L1. For the frequency list, enter L2 by pressing second and number 2. Highlight Calculate and press Enter. X bar represents the mean, and the problem asked me to round to 2 decimal places, so the mean is 18.79.